Good afternoon, everybody, and welcome to this webinar on the encryption dilemma. Today, we will address one of the major challenges and questions around bring your own key or all your own key. First of all, I would like to present the roundtable speaker. We have the pleasure to have with us today Bart Preneel, who is a professor at the University of Leuven, Geert, Baudewijns, who is the CEO of Secutec, and Dan Gleason, who is the CTO of Active Cypher. One of the main aspects I would like to highlight from Bart Preneel, as you know, is an authority in the cryptology. He's the head of the COSIC group, and Dan Gleason is the CTO and the founder of Active Cypher. Geert Baudewijns is the CEO of Secutec, Benelux, as I mentioned, and he will bring the pragmatical field view. My name is Renaud Larsen. I will be the moderator. I have the experience of the, let's say, to advise company from a security perspective. So, Geert, good afternoon. My first question will be to you to trigger the webinar. From your perspective, what are the major challenges organizations are facing today when it comes to encryption and key management? What you have seen during the last 2 years?
Well, good afternoon, Renaud. Regarding your question, what we see as the most difficult part in an encryption project is the user awareness and also how easy or how difficult is it to deploy it to 1,000, 2,000, 3,000 users without losing the management of this. And that's a very important thing from our side, or what we see with our customers, because what you see with encryption, if you encrypt your environment, your PCs, your workstations, or your servers, it's very tough when you have a problem, when it doesn't want to decrypt. So the question is, how difficult is it, or how easy could it be to decrypt, even if your support is not, or your support desk is not working out of the working hours, for example. So those are the most important questions when our customers are asking regarding encryption, how easy or how difficult this is, because we see a lot of companies working with big vendors. And then you have also people who are working with Microsoft, for example. And there is a big difference. The usability is a huge difference between those vendors. And that was, for example, my reason why I was very attracted by Active Cypher. The fact that a lot of vendors are taking encryption as a tick in the box, as an extra product, because they are a security vendor, they also have to do encryption. But then we see that the management of those kinds of solutions is not so very high or user-friendly. So that's from our point, what we see on the floor, what is the most important thing, and this is the usability of those products.
Probably what I will do is to ask to Bart Preneel his perspective from the academic, and also probably to clarify certain confusion on the market, because I think encryption is not equal to encryption, and people don't yet understand the different type of encryption from layer 0 encryption up to layer 7, which create confusion about how to select the right product for the right use case.
That's true. I mean, you have a lot of encryption possibilities, and when the most people are talking about encryption, the most people are thinking about workstation encryption. But like you said, there there are different layers of encryption, and that's very important.
Yes. So, Bart, what's your perspective from the academic field?
Thank you, Renaud, and thank you for having me. So academically, I think in some sense we can say that at least encryption of stored data, communicated data is actually solved. It means we have good solutions and we have standards like AES designed in our lab. So I think it's important to distinguish there between stored data, which I think is kind of easier, and communicated data, where indeed you have to look at all the layers, but I guess for most applications, we would prefer end-to-end encryption. What encryption does, actually, it shifts protection of data to keys. So the question is then, how do I protect my keys? And again, this has to be looked at for the context, both for stored data and for communicated data. For communicated data, and there is also the problem of interception. I mean, there is what we hear in the press about law enforcement interception, but of course, there is also the issue inside companies where they want to detect maybe for data leakage, or they may want to detect for malware, and then end-to-end encryption can be also a problem. So I think that's where the problems are more, is like where to encrypt or where to intercept them, and managing of keys. If I look at what the academic world is working on today, and there is also a lot of exciting startups in this field, is processing of encrypted data. Because in the end, if you use encryption, if you want to process data, you have to decrypt it again, it becomes vulnerable. And so there is some very cool mathematics now to make it possible to keep data encrypted and still do computation on it. And it's seems like science fiction is actually possible today for some limited applications at a very high processing cost, but there is lots of companies now in this space. I think it's very exciting.
So then from your perspective and from a product perspective, when I'm looking on both sides, from Geert, Geert articulated the challenges around the integration of encryption in an organization. And Bart articulated that today, yes, we have solved certain problem, but still we need to look at the key management aspect. But also today there are technology that enable to, let's say, do query or compute on encrypted data. From your perspective, then what were the main driver behind your product innovation and your let's say technical approach? What have you seen in order during the last couple of years, and what's your approach to solve or to propose, let's say, encryption that are integrated smoothly in an organization?
Thank you, Renaud. One of the things that I find, I'm listening to the conversation, and one of the things that resonates with me is the key management aspect. And quite frankly, when beginning the process of designing active ciphers and the data protection, data encryption, which we are data at rest and data in transit, where what Bart was saying is that a lot of products are data at rest, volume and disk-based encryption. But getting back to like our beginnings, the key management was everything. After the encryption algorithm and the protection schemas that we were going to be providing, key management became the absolute focus of everything, because we found that the technical staff was not prepared for that type of conversation of how do I manage the keys. They were faced with things like key rotation and who has the keys, and are they the identity that should be holding the keys. And so we worked that into the process, the whole key management. We tied it to the identity layer, we tied it to the machine layer, and we said that people are not equipped to be responsible to handle the key management. It's very technical, it's got to be done with schedules and, like I say, the identity verification. So what we did was we made a automated key management system to take that part of the conversation off the table, because this required technical staff to be involved, and it would confuse the business aspect of why we're encrypting to begin with, because the conversation focused around encryption techniques and key management techniques. So what we found is people were getting off subject into the technical aspects of the key management and away from the fact that they need to protect the data first, and secondly, the key management system should be taking care of all that for them, for the providing of the keys and protection of the keys. So that was the first thing that resonated with me that I had heard. Mm-hmm.
So, but this is, coming back to the academic point of view, and let's say the advice you provided to company, I'm still puzzled by the confusion that people are making between to bring your own key and to hold your own key. It sounds like, and probably you will enable us and help us to clarify who should own the keys and hold the key and control the encryption key, because it sounds like today, we are in a multi-cloud environment. People want to use the different vaults, but they don't realize that at the end of the day, how they can control, in fact, the keys and making sure that nobody has access to the keys. So from your perspective, how this confusion was created on the market, and what do we need to put in place in terms of best practices?
Well, I don't think there's miracle solutions, but I mean, you want to be in control of your keys, just like it's the keys of your door, physical keys, or the access badges. You want to be in control of them, which means that you can issue them and you can also take them back. And if they're lost, you can recover them. So you want a full control system of this. But of course, then the question is, where are they stored? Because you cannot, my physical keys are in my pockets, but this is, of course, different in computers. And so we know that if you put them in software, which is actually the easiest solution, then they're vulnerable to certain attacks. Right, so people can make dump of the code. There is tools to find keys in code. So then you're only as secure as your software is. This is why we have lots of devices like smart cards and SGX technology from Intel and HSMs to store keys more securely. And that kind of solved the problem. But of course, then the problem is who controls those devices, right? I mean, if an HSM has all the keys, then the question is who can authorize the HSM to actually do something? And you need, again, a key to authorize it. So you kind of just shifted the problem to something else again. And this problem becomes even bigger if you move everything to the cloud, because in the cloud, everything is in the VM. And so the cloud operator has access. This is the big debate going to Europe after Privacy Shield was destroyed and then Safe Harbor was destroyed last year. We had the Schrems 2 case, and more or less, if you have personal data, you should not have it somehow in the cloud, but of course your keys cannot be in the cloud. And if they're in software, then the cloud operator has access to them. If they're in hardware, if the hardware is from the cloud operator, how do you trust it? Right? Maybe there is a backdoor, and maybe there's a special command to export those keys. And you don't even know whether there is special hardware. I mean, if you're sitting here behind your desk, how do you know the cloud operator really has hardware, or is it a simulation of the HSM? And there is actually no HSM. So I think this is where we still have very big problems, especially if it's not under your own control, but on someone else's control. How are you sure your keys are safely managed? And I think this is a very big challenge. And I think so far, research has come up with only one answer, which is split your keys over multiple clouds or multiple HSMs or multiple devices, so that you actually need to compromise many of those and then hope that this will work. But of course, it brings a very high cost. But that's the only answer we have so far for this.
So then, from your perspective, how you have approached the challenge about holding the key and managing the key in such a way that from a corporation perspective, you enable company to manage the key, because on the market, there are a lot of key management systems. Should it be from Thales, from HITrust, you have many, but I think they're also, they are not equal. And still, the details are very important when it comes to key management system.
Absolutely. And everything Bart said resonated with me on our path as well. The key management from not only from the storage aspect, but from the architectural aspect of the key. What I'm saying is not the key material, but architecturally how the key management system works in a hold your own key or bring your own key type environment. What we had decided as we looked at these problems with the key management was that single point of attack, like Bart was saying, once you decide, okay, we're going to store it on an HSM or a hardware device, then that becomes that central attack surface, that focal point. Our decision was, we don't want the keys up in the cloud providers tenant or cloud host to be accessible by the cloud host. We wanted to maintain that the key would be in possession of the customer and not accessible by the cloud provider. And our approach was not to put the key material in one device and not to spread it across multiple HSMs, but we do not store the certificate key material in the HSM. We spread material out across multiple surfaces, database, storage accounts, and this is all stored in the client's tenant, the customer's tenant. Our decision was, don't create a service and put it in a platform or a SaaS in which you're sending data to and from it and encrypting it behind a wall, and do not send it to a cloud host where your egress, ingress of data goes behind a wall, and then there's some key management solution providing the encryption and it returns the data. Instead, put the keys up in the cloud provider's host for the customer. So the customer would own the key materials in their tenant and then secure the network access, the operator access, everything Bart's saying about the surface of controls. You need to tie all that down as much as you can to all the latest type of authentication, role-based, conditional access. And that's where focus is today from our standpoint, is know the identity of who's accessing the keys, know the identity of who's accessing all those control surfaces having to do with the management of those services in the cloud. So once you decide, I'm going to own my own key or bring my own key, then you have that responsibility of securing your key, like Bart is referring to. What we do is, once again, remove that management responsibility from the customer, and we provide a wrapping service. So our approach is protect the key above all else. So we will wrap the keys in session keys so that the key protection material is behind another layer of protection. And with that, you could even alter your encryption methodologies. Perhaps you have a non-standard, like an elliptical curve or QES type encryption key for encrypting and decrypting your data, but you can wrap that in another key material like an AES-256 wrapper tied to the identity and machine verification of the user. So what we try to do is secure the keys and tie the security of the key and that session material to things like multiple layers, like the identity, machine verification, authorization, and even today, attribute-based access control, so that there's a dynamic decisioning going on, like Bart was talking about, that when you have a single focus of attack, somebody can bypass certain credential type access to get to a control surface for a device or the key management. And if you increase that layering, attribute-based access control, then you're dynamically determining things and not just static logons and permissive models. So a lot of the authentication and authorization also has to be addressed when you're looking at accessing key materials and sensitive key device.
So a question to Geert. Based on the approach described by Dan, one of the challenges I see from a lot of company and administrator, as you know, inside the company, they want to be in charge and they want to, let's say, be in control. And of course, there immediately there is one challenge that we can put on the table. I call that the Snowden effect and challenges is, of course, when you have a system administrator, it could be an insider. So the point I'm making here, it's about, of course, the role-based access control and the way, of course, people might be able to manipulate even the encryption strategy, and then, of course, articulated the way to avoid that. But from your perspective, do you see resistance from, let's say, administrator or system administrator to move to a situation where, of course, they are not anymore in the same control when it comes to the key management system. In fact, they delegate to the system based on the profile of the user, and they don't have to define the profile of the user.
Yeah, it's there's several answers on this. I think you have customers who are not interested in where the keys are. They just want to be sure that things are encrypted and that the data could be stored in Europe, for example, or in a separate zone. For them, it's not so. There, the usability is much more important than the fact where those keys are and how technically this solution works. On the other hand, you have also organizations where this is important and where they say that the fact that we are managing ourselves, our keys, is much more important than the fact that we don't know it, and that for example, a state could also read our data because it's, for example, an American vendor. So this is, I think, a very important part where we can say that, okay, this is, if we manage this by our own, at least we are sure that other people cannot read this, and that's a very important fact, or a very important feature where other companies cannot read, where you are sure that it's not they are not able to read the data and follow your conversations. So I think there are two kinds of customers. One, the customers who are looking for simplicity, and the other part are the customers who are looking for a much higher solution, and where they are sure that the keys are simply managed by their own and it's not able to read with them.
So, Bart, a side question. Do you think, and how do you view also related to the complexity of homomorphic encryption as a candidate for next generation protection data? How do you view from the academic perspective? As we know, Intel is working a lot on that. How do you see the advantage and the disadvantage of this type of solution?
Yes, I think that the point is, of course, that if you process data in a computer that's not your own and you not control it, then I think you somehow have always a weakness, right? I mean, if you process data in the public cloud, you may have the best key management. In the end, you have to decrypt the data and do operations on it, and then maybe re-encrypt it. But while the data is being processed on, it actually is vulnerable. So the only way to really protect with normal technologies is to have your data in a private cloud or on your own on-prem, and not in the public cloud. So there is one exception, which is these new technologies, and due to marketing, full homomorphic encryption is actually better known than MPC, multi-party computation, but they're both complementary technologies. And so they allow you to process unencrypted data. So your data remains encrypted. In the homomorphic encryption setting, you send data encrypted to the cloud. The cloud operator performs some operations on it. You can even keep the operation secret, because it's a secret algorithm to compute something. It can also be a known algorithm, and he sends you the encrypted result back. This means the data is never decrypted, and so your data can be in the public cloud and still it remains secret. So I think it's very nice. We have to be very honest, though, the overhead is huge. So 1 bit becomes 100,000 bits. So it's like a factor of 10 to the 5. You can also not do any computation. So the number of multiplications you can do after each other is very limited, but you can do things. You can do statistics, averages, variances, third order products are possible. We have done a project where we showed genomic analysis, very specific analysis. You can do, of course, not a full analysis, but there is some genomic analysis you can do. We have done electricity consumption prediction. So there is some things you can do, but it is limited to rather simple things. With MPC, multi-party computation, you have a different strategy. You take your data and you split it up over multiple devices, say multiple clouds or multiple servers, and you assume that not all of them will be compromised. So maybe the NSA gets hold of one and the KGB gets hold of another one, but in fact, nobody can get access to all the servers, and then you can do computations. And this is, I would say, slightly more efficient. You have a very huge communication overhead now, but a very low computation overhead. But your data is never in the clear, and the result again can be encrypted. So these things, for example, I don't have shares in them, but I think there is very nice solutions in companies like ShareMine from Estonia. There is Unbound in Israel that actually offers solutions based on this. And again, you can't do everything. The cost is high, but some things can be done without ever having your data in the clear. And this, I think, is definitely a solution for the future, but there is a high cost. You have to be very honest. It's not going to replace Google's processing, or it's not going to, for daily bank transactions, it's still not ready, right? It's not for gigabytes and terabytes of data, but very specific confidential data is definitely a possibility today.
So to elaborate on what you articulated, do you think that we might see during the next couple of years, and I will also ask Dan to comment on that, that based on the use case, even inside the corporation, we might need to look at different encryption strategy? Should it be, let's say, for mission critical data, for very sensitive data, there might be different approach from an encryption point of view? Because it sounds like, based on what you said, to avoid, let's say, of course, certain technology, there is a usual variety, so you need to pick your battle and to identify the use case. Do you see already organization discussing with you from an academic perspective about recommendations, saying, you know, do we need to look at different encryption mechanism and different encryption strategy?
Well, there is definitely a high interest in FHE and MPC, and it's driven by some companies, also driven by academic research. I think it's more complex than just encryption, because just encryption, as we discussed, you have to choose the encryption method and the technology, and you have to do the key management. I think our experience is that with these advanced techniques, you have to redesign your processing algorithm. So you can do a neural network, you can do AI, but you have to redesign your AI so it fits the solution, right? Or you have to redefine your algorithm so that actually it fits the solution, but it can be done. And I think for the next 5 years, I say it's still a niche thing, where they have specific processing forms you want to do, and you can do them in the encrypted domain, but you have to re-evaluate, redesign your processing algorithm, and then you can implement these technologies. So I think this is how it will go step by step. More and more techniques will be possible. But again, we should be very honest. I don't think that all kind of processing is possible. There will be a limit where the cost will just be too high. And people will go to on-premise systems, or will just trust the cloud and hope that nothing goes wrong. I think that's going to be the solution there.
So then, from your perspective,
I see that, you know, it's hard to say, like, from a generic standpoint, what, you know, like a silver bullet that takes care of all type of use cases. So as I hear the discussion, you know, I'm thinking about where the workloads are too, because the workload processing location where you're doing the encryption, decryption, accessing of the data, that's a vulnerability as well. If you're moving everything into the same location, whether it's in the cloud or on premise or on a server, then that focus of all the activity of encrypting the data, accessing the data, checking identities, authorization, it's all in one location. That might not be the best approach. You know, it's like a common sense type of thing. Spreading out the areas of concern, spreading out the surface areas that can be attacked, not putting processing in a vulnerable state in the cloud provider. I hear, you know, a lot of discussion about, you know, cloud provider and access that the cloud provider might have to keys and the encryption process. But, you know, you can separate that. We create secure private clouds for each customer where the key material is stored, but we're not doing the process there. We're not doing the encryption inside the cloud. So we store key material in the cloud, but the encryption in a use case, and these will vary, but let's say you have an on-prem file server or banks of file servers where you want to protect the file data. Starting from that file data perspective, we would store the key material up in the secure private cloud, but do the encryption process itself on the file server. And so we're not sending unprotected data up to the cloud to be protected and then back down to the servers. Now that sounds like common sense. Why would you send data offsite to encrypt it and then return it encrypted? But in checking with, with providers, security providers, if you're able to get to their layered architecture, you'll find that a lot of providers that are platforms and SaaS are doing just that. They say, well, we protect the data, they're providing like SSL protection of data that's unencrypted out to a cloud provider, doing the encryption there, and then returning the encrypted protected data. So it really, when you take a look at the whole layer of where the processing is getting done, where the areas of concern are, the data concern, the key material concern, and user access. You have these things separated, then you have a little, more protection to your schema there. But you have to first peel away, where is the data? Where is it going to be processed? Where is it going to be sent to? These things must be looked at. And when I say sent to, that means consumed. Like, know who's consuming your data. Your data should be encrypted, and our zero trust, viewpoint is it's zero trust of data, that the data should not trust anything. So as the data travels from one point to another, the process of examining who it is that wants to access this data needs to go through the steps, not just a key exchange, but who are you? Where are you? Are you in a cloud? Are you in a company location? Where physically are you? The device, is it a managed device? All these things are like network techniques and system techniques that have existed for some time, but we need to be applying these things, the authentication, the authorization layers, attributes of where they are, who they are, what time it is. Are these things unusual or not? Is this a common thing? All those things need to be evaluated in the entire system, because you don't have enough people to monitor all that. Who has these keys? Are they fresh? Are these keys before being used? When's the last person the person was authenticated against the identity system? You want to have periods of time that the person's re-authenticated, challenged before that key material is accessed to decrypt things. So I look at this as a large onion in which you're peeling back those layers of identity, authentication, authorization, the attributes, until you get to the core of where we have high confidence that this is who they say they are, where they say they are, doing what they should be doing. So we're going to go on and decrypt the data and present it to them. So just as we went through the learning process, discovery process of protecting the keys, we also realized that before you access these keys, make good, make a lot of checking that who's accessing these keys before you hand them off to them. So it's part of a larger system that has many control surfaces that need to be evaluated, not just by us. That's my opinion, that any system should go through these peeling of the layers before these key exchange and handoffs are done.
So Geert, with everything we describe, we have an elephant in the room, which is of course GDPR and the highly regulated organization. Should it be an hospital, a financial institution? And as you know, Geert, the correlation between GDPR and different compliance standards, it's a very complex one. One of the aspects that I've seen is the GDPR fines are increasing dramatically, especially during the last 18 months. As you know, we are close to 400 million euros. There were huge fines, like for, let's say, the British Airways fine. But one of the things that surprised me always is, as you know, in GDPR, there is no, let's say, technology recommended. There are only anonymization and encryption, why companies are not just encrypting the data just to be, let's say, aligned with the GDPR regulation and to be, I call that, to be on the safe side from a zero trust perspective. Why they do not do that systematically? Because I think today what we have seen is last week there were multiple hacks, you know, the picanol situation, and also if you face ransomware, to be encrypted, help you to avoid certain, let's say, major challenges.
Well, that's a good question. First of all, I think that most companies think that everything what's happening within their own company is already secured. So that's a very important misunderstanding that a lot of companies have. Second part is when you, it's not always so easy to start an encryption process on an active environment. I can imagine that it would be very hardware intensive when you're talking about databases or very, very big databases who are active on 24-hour base, and where you have to do an encryption and decryption process on the same moment. So that's a part where I can imagine that would be very, very difficult. But the most important problem is that persons or the CEO, CTO is thinking that the data, what's internal in my organization, is already safe, and we don't have to encrypt that as an extra layer. Or they just think that it's for my computers who are outside of the network. That's the first part of an encryption. If we encrypt those PCs, then at least we are secured. And if something would happen, the GDPR legislation would say, okay, we have encrypted our PC, so there is no problem. But that's not the case. That's really not the case.
And maybe I can add on to that. I think one of the problems is, of course, that you cannot make legislation technology specific because technology changes too quickly. So GDPR is quite technology neutral. And indeed, as Geert pointed out, companies are very minimalistic. They have taken a checkboxing approach. They called in consultants who said, we're going to identify your data, you're going to check all the boxes, and then you recovered everything. But then if you look at those boxes, they still have username, password for login, which is kind of, even, I think everybody agrees that is for any sensitive data not adequate anymore. But even that, they still believe that this is sufficient, and then they're surprised that there is a breach. So, but of course, if you go into detail in GDPR, you will find out it speaks about privacy by design, data minimization. So you should not store more data than needed, and should actually minimize all this data and not centralize things and not store more than needed. But this approach has not at all registered. And I think it will take indeed some time before companies will invest more and realize that checkboxing was not enough to avoid fines. That's going to take quite a while, I think. It just takes time.
Do you think, Bart, that as a let's say ecosystem, we have not done the correct job, especially when we look at the GDPR, to translate the legal wording in what's in it from a technical point of view? What is translation? I'm always taking, for example, the notion of, let's say, data processing. And when I'm speaking with corporation, sometimes they speak about, yes, processing in our data center. They don't look at GDPR as a transaction. And what's your perception? Do we need to really do a deep awareness and to educate and still evangelize, even if, you know, people think, you know, GDPR, it's already, it was in 2018, we know, and but still, they have not done the proper implementation.
Well, I think, as I said, I think what happened is that there has been a legal interpretation which focuses on, you know, make an inventory and then check the boxes and make sure the management is aware of the problems. I don't think there has been an effort to really increase the baseline of security a lot and to have a continuous process to improve things. I think also on the side of enforcement, we have to be very honest, enforcement has been very weak. Right? There have been some very big fines, but how many companies have been checked? How many companies do you know where actually the DPA went in and said, we're going to check your practices and whether you protect personal data? it only happens after a complaint, and even then, it's also clear that in Europe, the DPAs don't have enough technical people to do such audits. Right, so the enforcement, I think if you have a weak enforcement, you shouldn't be surprised that also the implementation is weak. And so I think if we want to get stronger implementation, we have to have a stronger enforcement. And then I think more companies will understand that they have to have stronger encryption, they have to improve over username password, and they really have to increase their baseline security. But for now, I think it's a cat and mouse game with enforcement. And of course, we see large fines, but in the overall picture, the number of fines and the level of fines has still been very small, I would say.
So then, looking from your perspective, from the US perspective, in a highly regulated environment like the financial sector, how you see and to address, for example, the big data challenges, meaning the analytics from a bare metal perspective when it comes to the encryption of data sets. What would be your approach? Because there, it sounds like, should it be Bank of America or other organizations that are really facing major challenge to protect the data set, which is the jewel when it comes to, let's say, the trading floors. And it's a highly regulated environment.
Yeah, I think, the financial institutions have learned something from some of the breaches and fines that have happened here in the US, so that some security advisory and consulting companies have taken on several products and suggested frameworks for protection nowadays. Without mentioning names, what I'm saying is the financial institutions faced with this type of problem of the massive data loss of these very large data sets and things like that. There's been, like Bart had said, checking the boxes. There's some consulting recommendations that come in, and it's like, if you do this, this, and this, then you've got a good starting point. Our approach is one in which focus on the data first. So when you say data sets, to me, that you have that unprotected data that, if we're not talking about the processing of it, but the actual storage and transit, movement of these, of data and files and things like this that are vulnerable, that it's not the process itself or the framework of how you're going about the isolation and protection of the perimeter and access to things. Even, these things are like good practices to be doing, but a lot of companies aren't focused on that actual data encryption problem per se. The problem is the data is unencrypted. We're looking over here at the perimeter, at access, at verification and firewalling to prevent the access to the data, but they're late on actually encrypting and protecting the data itself. And so from our point of view, it's changing the focus to first protect the data and tie it to your authorization systems and identity systems. And you could add perimeters, you could add the layers of protection from an access standpoint, but to first focus on that data encryption. And that sounds like it's the common sense, thing that if you're going to protect your data against data loss, the first thing you do is encrypt it to make it difficult that if it's in the wrong hands, that it is meaningless to those people. And that's the GDPR answer as well. When we deploy to Europe, we're deploying to the cloud centers, the data centers in Europe, and it's a secure cloud in that Europe data center with the keys and processing up there. But the data has been protected up there and encrypted up there. So if that encrypted data ends up on devices that are unprotected, the data is still meaningless. And the actual, in America at least, that data loss will have to be reported as a data loss, but you're not notifying the individuals that their identities have been lost, because in fact they haven't. The encryption protects all the identities and PII of the people that are in that data set. So by encrypting that data first, you've lost data in the sense of my file is gone, my very large data set, but it's meaningless. It's gibberish, because that data encrypted would not be able to be accessed by anybody. So it's changing around the focus from all that protection of and isolation of who gets to the data, the perimeter and stuff, and just focusing on protect the data first.
So, but often we hear on the market the notion of encryption at the application level. And we know that in most of the case, you need to re-engineer the application, and it's complex, will take a long time. And of course, you can introduce new bugs or new vulnerabilities. So based on this challenge from an application point of view, when it comes to encryption, according to you, from an academic recommendation point of view, from your experience point of view, what will be the level acceptable to be, let's say, really aligned with GDPR as a regulation and with other, let's say, compliance standard?
I think it's a very good question. It's very hard to answer. I mean, it can only be given in the context, because GDPR says you should do a risk analysis. And actually, the GDPR doesn't require unlimited protection. It says, look at your risks and make an analysis. Of course, maybe an academic answer would be encryption is now very cheap. So just encrypt at all the layers, right? I think we come from a time 20 years ago, encryption was very expensive. Today, encryption is cheap. I mean, your Intel processor, your ARM processor encrypts a byte in less than 1 cycle. So it costs much more to decompress a picture than to actually encrypt the picture. So of course, that's a bit of an easy, unfair answer, because of course you have to do with the key management. But encrypting your disk, of course, is very easy. Most of us actually have encrypted disks, because if you buy a disk today, it's encrypted. The thing is, the key management, you have to pay for it. So as a consumer device, your disk is encrypted, but anybody who plugs in the disk in their machine can also read all the data. So there is no protection. So I think definitely I would say you should have this level of encryption, because if people steal your disks, you don't want them to be able to read it, but that also means you have to have the key management, which is the cost of it. But in the end, of course, if somebody can compromise your application, the application has a web interface and people can do cross-site scripting, or they can find the buffer overflow in your application and they can enter the application, then this encryption is not going to help you, right? Because they will be able to go inside the application and query the data from the application, which will be authorized. So I guess as an academic, I have to say the strongest level of encryption will be in the application. But I would not say it's either or. I think you should really consider whether you can do both. And what you do exactly is determined based on a risk analysis you have to make. That would be my answer to this question. It's not a simple answer, definitely.
Then feel free to complement, but I have a sub question when it comes to the backup. So we have encrypted the data and we do a backup. Is the backup also encrypted? And if so, is it good practice to keep the same key or to generate another key? The same key as used for the primary data. How to have the best approach from a management point of view when we need to manage the primary data and the backup. From your perspective, Dan, what will be your recommendation?
Well, it's separation of concerns. It's the data backup. Who's going to be accessing that data backup? You have the backup operators, you have actual system accounts and service accounts that access these things nowadays. So it's not anymore that you have a user logging into a workstation or a server. You also have these services, so applications and APIs that are operating on behalf of a service account or on behalf of a user who's accessing these backup and recovery sets sometimes. So if you allow those service accounts to have access to that data, then you have these surfaces that are vulnerable, in which somebody compromising, not a user account, but not commonly accessed service account, having access to that data is a vulnerability. So our approach is that you encrypt the data into the backup volumes that you need for storage, but that you allow privileged access to that data, controlling the service layer of this as well. So in other words, you're not just turning it over a decryption key to a service account or a backup service to have access to decrypted data, that it's a two-part thing, that the data is encrypted separate of any type of decryption service for access to backups or movement of data. And then the people, the persons, the roles of people who are operators of that data, they are not participating in any key membership group that has access to the decryption of data. So backup operators, system admin people, they are not participating in the key management for that data. They're only participating in the data access to be able to move this data around, to move it to other systems, so it gets consumed into other backup systems. So it's isolating the people, processes, and services from that data layer and not allowing the services and account operators access to the same key material, meaning the groups and other distribution methods that you have for the keys, separate of the data, keeping those two separate.
Geert, so from your field perspective, we see, of course, today, corporation went through the virtualization. Now we are moving to microservices and the adoption of containers. How do you view the way they will address the challenges around, of course, securing, the containers, and we can say the repository of the containers? How do you view the approach today? And we can say let's say the concern.
Well, the concern, I'm following you. Concern is how easy is it to do the usability. That was my first point. The second point is you can be. I think that in the future you will need more than just encryption by a key. The only thing that you have is a key, and where you can compare and to decrypt your data. I think that's a challenge that I want to give to the people who are involved in encryption and decryption, is to go a little bit further and even to see what we are doing, for example, for banks, to do with Java injection, to do it as a multi-factor authentication, for example, where you say that, okay, before that you are able to encrypt or to decrypt something, to do a second test and to see if the user is really the user and that you are not using or not in between a man-in-the-middle attack, for example, for somebody who's reading your data. And those things are for me, the next generation of encryption, where you are able to see before your encryption and decryption process is launched, to do a second channel and to do a Java injection, just to be sure that the people or the communication between A and B is the right communication and there is not a C in between. And that could be, that's what I would suggest to be as a next generation encryption model, to incorporate not only the encryption, but also a second connection or a second layer of an identification, just like the same as what a bank is doing. Before that you access your portal, your bank portal, your secure bank portal, your bank will do a Java injection to be sure that it's you as a user and that you're accessing with a device that is known from your perspective. So that would be a a second or an extra layer, what I would suggest to incorporate.
Dan, anything you wanted to add?
Yeah, that's exactly what we've evolved into, Geert, is that our realization of that problem with the key, that a lot of systems were just handing off the key. Oh, you need a key to decrypt this, here you go. That's where we had tied it to, well, slow down with the key here. Let's validate the identity. Let's authenticate the user, but let's authorize them too. Let's check the machine level as well as the identity. So one of the things we do is we'll take the key material and wrap it, like I said, in a session key, a user key. That user key is a PKI or asymmetric process. That's more like a banking process where you have the X509 certificates. You have certificate on your machine, validates your machine, and then you're authenticated, your username and passwords authenticated against the backend identity system. So you have the machine validation as well as the identity validation. And then our approach is, okay, that was a good start. Now let's also look at the device as in, it's a managed device, but where is this device? And is this user commonly logged into this device? What type of activity is going on with this device? Is there a lot of files being opened? So we look at behavior, the distribution of the keys and validation of the identity in the machine. We can then, like you're saying, have some faith and confidence that when we unwrap that outer session key to grab the inner key material, that we've gone through all those layers, if you would, machine layer, the identity layer, the user behavior layer, which is more at the application networking layer. So we're binding that key access and key distribution to multiple layers of investigation and validation before presentation.
So, Bart, we are close to the top of the hour, and I would like to give you the floor to for the conclusion and the three main points that we need to keep in mind out of this roundtable discussion. What are the main points for you we need absolutely to keep in mind while we are working to secure our data?
I think it's important to note that encryption is a very powerful ally to protect data, but it's not a magical solution. You always have to manage the keys and integrate it, as the other speakers have said, to the application in a secure way. I think that's an important takeaway. I think also important that encryption has become cheap. There maybe people may still have this idea that encryption is expensive. I mean, key management can be a cost and complexity, but encryption by itself is very cheap. So there is no reason not to encrypt things. I think some other messages are that you still want to minimize data. I mean, if you want to be compliant with GDPR, it's not enough to check the boxes or to even encrypt all your data, but actually the first step is minimize your data and do privacy by design, which is a slightly different step away. I would also say at the architectural level, we should maybe put less data in the cloud because maybe the pendulum is swinging back, right? We had the mainframe, which was centralized, the PC, what was decentralized, now we have the cloud. And now you see, for example, we see more edge computing, local intelligence. Maybe we should keep more data local, still protected with encryption, and using some of the magic crypto techniques, we can still get value out of data that's local, protected, but still in the future, we'll be able to get value out of this data using more sophisticated things like MPC or FHE techniques.
So with that, I would like to thank you very much for this roundtable and for all the audience and attendance. So I hope we will be able to organize another webinar on security by design, for example. So thank you very much. Have a nice day. Bye-bye.